Today, we're going to break down exactly how you can transform a general all-purpose AI into a razor-sharp specialist. This is the blueprint for fine-tuning. You start with this incredible, genius-level AI, but the real challenge is teaching it a very specific new trick. The secret to doing that is a structured process we call fine-tuning. We're going to walk through this in 4 key phases. First, we'll look at the overall blueprint. Then we'll dig into the foundation. That's all about the model and the data. After that, we get to the exciting part, executing the training. And finally, we'll cover how you perfect the model through evaluation and iteration. Okay, let's dive right in. The whole process really boils down to a 6-step journey that takes you from a general model to a highly specialized AI. And here is that full roadmap. It all starts with defining your use case. From there, you curate your data, get the model initialized, and then train it. After that, you've got to evaluate its performance, and finally, you iterate on that process until it's perfect and ready to deploy. That's the entire workflow, from start to finish. Now, those first 2 steps are absolutely everything. They're all about laying a solid foundation. If you get this prep work right, you're setting yourself up for success down the line. It's that critical. So, the very first thing you have to do is get crystal clear on the problem you're solving. This isn't just about project planning. The specific use case you define is going to directly point you to the right pre-trained model to start with. When you're picking that base model, there are a few key things you need to weigh. You have to think about the model's size and its overall capacity. Does it align with your specific field, like finance or healthcare? And practically speaking, what kind of computational power do you have? You also want to see if there are pre-trained versions, we call them checkpoints, that can give you a major head start. And this leads to a pretty big decision. Do you go with an open source model or a commercial one? Open source gives you incredible control and flexibility, which is perfect for custom, groundbreaking work. But it does require more technical skill. On the other hand, commercial APIs offer easier access and great support, which is often the best route when speed and reliability are your top priorities. Okay, so once you've chosen your model, the spotlight immediately shifts to the single most important ingredient in this whole recipe. You've heard it before, but it's never been more true. A model is only as good as its data. And that brings us to step 2, curating your data set. Look, in fine-tuning, quality is so much more important than sheer quantity. Your data has to be top-notch and directly relevant to your goal. This means getting the labeling just right for tasks like classification, cleaning out all the noise and junk, and then pre-processing it so it's in the exact format the model needs to understand it. All right, with that solid foundation in place, it is time for the fun part. We're moving into the execution phase. This is where we actually bring the blueprint to life and train the model on its new specialty. Step 3 is all about getting the model ready. We start by loading up its existing knowledge, all those pre-trained weights. And a really powerful technique here is to freeze some of the model's layers. And this right here shows you why that's such a game changer. By freezing the earlier layers, we lock in all that powerful general knowledge the model already has. Then we can focus all our training effort on just the later layers, allowing them to adapt and learn the new, specific patterns for our task. It's really the best of both worlds. And now we're at the heart of the operation, training the model with our special dataset. The process is a loop. You feed the data in batches, the model makes a prediction, you calculate how wrong it was, that's the loss, and then you update the model's internal wiring to make it a little bit better next time. So how does it actually learn? Well, the magic behind that loop is an algorithm called backpropagation. In simple terms, it's what calculates the error, or the loss, and then it works backward through the model, tweaking all the internal weights just a tiny bit to reduce that error in the future. That's it. That's the learning process. Now, one of the trickiest styles to get right during training is the learning rate. It's a real balancing act. If you set it too low, you get really stable, gradual improvements, but it can take forever to train. If you crank it up too high, training is much faster, but you risk the model making such big jumps that it actually forgets the valuable knowledge it started with. And while that training is chugging along, there are a couple of other key practices that are just essential. You'll need to tweak the batch size, that's how much data the model sees at once, to find the right balance between memory use and how often it updates. And trust me on this, you have to save checkpoints regularly. They're snapshots of your model's progress, and they will save you if something crashes. So, this brings us to the final, crucial phase, perfection. This is where we put our model to the test. We refine its performance, and we get it ready for the real world.
Step 5 is all about evaluation. After you've trained your model, you have to test it on a completely separate set of data that it has never, ever seen before. This is the only way to get a true, honest measure of how it'll perform in the wild and to make sure it hasn't just memorized the training examples, a problem we call overfitting. And measuring success for these language models is a bit of an art. We look at very specific things like accuracy, completeness, and how concise the answers are. We also use standard industry benchmarks like MMLU or Rouge scores to grade performance. We even check a hallucination index to make sure the model isn't just making stuff up. And that brings us to the final step, step 6. You have to remember, fine-tuning is not a one-and-done deal. It is a loop. Based on your evaluation, you'll almost certainly go back, tweak some settings, maybe refine your dataset, and then retrain. You repeat this cycle until you're happy with the performance, and only then is it ready for deployment.
So the real takeaway here is this. Fine-tuning isn't about building an AI from scratch. It's more like being a sculptor. You start with this huge, incredible block of general knowledge, and you carefully chip away, refining and shaping it until a specialized expert emerges. This blueprint, it's the chisel that lets us create the future of AI, one specific task at a time.